Hi guys, so today's about scatter plots. Hopefully you got a pretty good idea yesterday what these are about, or today if you finished earlier and you're watching your video. Go ahead and get your notes out. Title today 7.3 scatter plots. You're going to take notes with me through the video. You can pause it, watch it, re-watch it, try the examples, make sure you got them right. But here we go. So write this definition down in your notes. So pause this and write the definition down. Alright, the two things I want you to underline are two data sets. Every time you do a scatter plot, it has to be two sets of data. So yesterday you did your hand versus your height. You could do how long you study versus the score you get on a test. It's always going to be two sets of data. We'll always put them as ordered pairs. So those are the things I want you to underline. Why are scatter plots useful to us? What did you do yesterday with your scatter plot? How did you use it to solve the Jolly Rancher case? So scatter plots are really good for making predictions. The example that I always use is, some of you probably have siblings or cousins or whatever, where you've heard, oh, they're going to be 5'10" when they're 15 years old. Well, how do they do that? They use a scatter plot. The doctor has plotted many kids when they were 2 years old and when they were 15 years old, and they have seen a pattern. So after they see a pattern with so many people, they can start predicting when you're 2 years old about how tall you will be when you're 15 years old. So scatter plots are very useful in that way. Now, I'm guessing after yesterday you have a pretty good idea what to do with this already, so why don't you pause this to try to answer these questions. If not, come back and we'll answer them together, or try one or two with me and then try a couple on your own, but I think you probably have a pretty good feel for this. So, scatter plot shows the fat grams in a sandwich as compared to the calories in a sandwich. So here's your fat grams, here's your calories. So what you're going to do is, through the middle of this, we're going to draw kind of a line that we think fits it the best. Now, we don't need to connect all the dots. If you think of all those little dots as being a magnet, they're all trying to pull on that line, so you're trying to balance the line between all of them the best you can. This is called the line of best fit. This is the line we're going to use to make the prediction. So, how many calories are a sandwich that contains 17 grams of fat? 17 grams of fat would be about right here. If I connect that over here, that would be about 450 calories. So hopefully you got something similar to that. We want to use the line because you can think of a line as kind of being an average of all the dots. We don't want to use just one dot. We want to use what we know about many of them to help us with the general idea. How many grams of fat are in a sandwich that contains 600 calories? So if we go here, I'm going to say there are about 32. Now maybe yours looks a little different if you drew your line a little bit differently, but should be pretty close to that. What tends to happen to the number of calories as the number of fat grams increases? Now, as we get more and more fat grams, we get more and more calories. So as the number of calories goes up, the number of fat grams goes up. And again, try to answer these, pause it and come back to it. 650 calories based on the scatter plot. What would you expect it to have for fat grams? So 650 calories would be about right here. I'm going to say it's going to have about 37, 38 fat. So that's the dealio there. Okay, you are going to have to label positive, negative, or no relation at all. I think that this should be pretty intuitive because we know with slope, if you're going uphill, so if you have this little dude, standing over here, and he's taking a hike across the page. If he's going uphill, it's positive, downhill is negative. Now this one over here has no relationship whatsoever. There is nothing going on. I can't figure out if we're going uphill, downhill, whatever. So something like that would be, maybe we plot how much rain we get depending on the day of the week. Does the rain know that it's Wednesday and does it care? There is not going to be any relationship to something like that. write those down, pause it, jot that down. Next one here. So take a look quick. And sometimes in your homework and on the test, sometimes I'm not going to give you the graph. Sometimes I'm just going to give you this right here. But if we think about this, and you know this, as the size of a TV gets bigger, what happens to the price? The price goes up. If they're both going up, if they're both going in the same direction, it's always going to be positive. And we can see that here, it's going uphill. The age and the number of pets. So, as your age goes up, does that change the number of pets that you have owned? Now, actually, if I were thinking about this, I might think that the longer you live, maybe you've been through more pets, so maybe we would see something positive, but I guess maybe if you don't like pets, you don't own any, no matter how old you are. So if we look at this data, we're going to say there's no relationship whatsoever. This says go ahead and make a scatter plot on your own and then tell what you see. Sometimes you don't even have to do that. Sometimes you can just look at the data. So if I look at this data right here, the age of the car is going up, 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 up. So the age of the car is going up. And if I look at this is going down, 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 down. So if they're going in opposite directions, this is going to be negative. And if you're not sure, go ahead and plot it. You could go over 1 up 24, over 2 up 21, over 3 up 19, and you would see that going on. This one here is a little bit harder to tell because they're not in order. Because this goes down and then up and then up and then down and then down. So this one we probably would want to take the time to plot it, but we could also just think about it. We better know the answer to this. If you study more time, the more and more you study, what should happen to your test score? Your test score should go up. So this one should be positive, and if you're not sure, go ahead and plot all those dots and see what happens. Line of best fit. This is going to be the tricky part. This is going to be where you're going to want to pay more attention and you're going to have to go a little bit slower. So, write this down. Put that in your note. Put this in your notes. And we already kind of drew it on the last page. So, if they give us the data, here's the data, and they wanted us to plot it, but they did it for us already. So we plot over 1 up 19, over 2 up 15, over 3 up 13. We plot all that data. The line of best fit's going to go through all of these the best we can. Again, we don't want to hit every single line. We don't want to hit just the top one and just the bottom one. Pretend that these are all mini magnets, and we're trying to balance that line between all of them the best we can. Now this is going to be tricky to check your answers with the person next to you and for me to grade because we're all going to be a tiny bit different, but we should be close. Okay? So now here's the tricky part. Here's what we have to do with that. So this says to make the table of weekly sales. This is make the scatter plot. We already did that. That's here. They did it for us. Draw the line of best fit. They did that for us as well. Write an equation for the line. This is the tricky part. This is where we got to remember what we already know. Now, what do we know about a straight line? Hopefully, we all know the equation for a straight line is what? It is y equals mx plus b. Remember, you got a starting amount and a changing amount, a starting amount and a changing amount. What do each of those stand for? This is going to be your slope. This is going to be your y-intercept. And remember, what is slope? Slope is rise over run. Put this in your notes. Okay, so I draw my line. Now, as long as your line is pretty much in the middle of all of them and it looks reasonable, you're going to get all your points. And as long as this equation reflects whatever you drew on your paper, you'll get your points. But every single one of us could be a tiny bit different depending on what angle we draw the line on. So my y-intercept's really easy. I can see that. It's right here. I don't have to guess very much. I can see it. It's plus 20. So that's going to be right there. Now, how do I find my slope? You can find your slope from any point anywhere on this graph. I would pick ones that cross nice and pretty. Like this looks like it crosses good. This looks like it crosses good. This looks like it crosses good. They happen to pick these two. You don't have to. If I look at this, rise over run, this is going down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Remember, don't count blocks, you got to look at the numbers. So my slope here is going to be negative 2 over 1, x, or just negative 2. Now back to the doctor's office. Do you think when your little cousin walks into your doctor's office that the doctor pulls a giant graph out of his back pocket and plots your cousin and looks to see where he's at? He doesn't. He has an equation. He says, okay, well, if you're this tall today, I'll multiply you by something, and then I'll add something, and now I know how tall you're going to be when you're 16. So equations make things very easy. It says make a prediction for sales in 9 weeks. So predict, weeks is your x, so predict when x equals 9. You've said all year there's 2 ways to do that. Method 1, you can look at your graph. So you could go over here and you could look at your graph and we would get that the answer is about 2. What is method 2? Method 2 is that you could use your equation. So let's use our equation. 9 weeks minus 2 times 9 plus 20. Negative 18 plus 20 gives me 2. I got the same answer. Now, you're not always going to get the exact same answer because sometimes your drawing is a little crooked or you estimate a little off or you can't tell for sure. But these two numbers should be very close to each other. Okay, so last slide, pause this here, try this on your own, and it's going to be kind of crappy, but I'll try to do it with you quick. So pause it, try it, and then I'll run through it really fast, because I don't want to run out of time, and it's going to be really ugly. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. We're going to go 400, 800, 1200, 1600, 1200. So over 1 up 420, over 2 up 500, over 3 up 650. Okay, so my line I'm going to draw it somewhere in here. Okay, so I just graphed it, I drew a line, write the equation. Now, y equals mx plus b. I got 1 minute left, I got to hurry up. My y-intercept's going to be right here about maybe 0, and again, if you got to use graph paper because this is really crappy, so I'm probably going to be pretty far off. Maybe 20. I'll say it doesn't look like it's quite 0. I'll say maybe it hits at 20. Now my slope, I can pick anything on here. I'll go from here, anywhere on my line. It doesn't matter. I'm going to go from here over to here. So it looks like to me I go from 20 up to about 700. So I go up about 680. And I go over 2. Okay, and again, this is really, really crappy because it's shaky and I need straight lines. So up 680 over 2 is about 340x. So there's my equation. Now it says make a